Okay, we're going to be talking about Algebra 2, the second 9 worksheets, practice B. Again, the first problem says, given the following equation of a parabola, write the transformation, vertex, and axis of symmetry. Graph it moving the points of y equals x squared correctly. So we're taking what we did last 9 weeks about transformations, and we're kind of adding in some parts of a parabola, and we want to see how those transformations affect the parent function y equals x squared. So if we look at y equals x plus 4 squared, since it's a plus 4 inside the parentheses, that tells me it's going to move it left 4. So my transformation is move left 4. So what that means is I want to take every point over here of the 5 points that I have graphed and move it left 4. So 0, 0 would go 1, 2, 3, 4 to the left. This point, 1, 2, 3, 4 to the left. 1, 2, 3, 4 to the left. It just so happens that when I move this one 4 to the left, it ends up being on this one. And then move this 4 to the left. And then I'm going to graph my new parabola. Now the vertex again is the lowest point or the highest point. In this case it would be the lowest point of the parabola, which is right here. And that's negative 1, 2, 3, 4. So the point negative 4, 0. And the axis of symmetry is that imaginary vertical line that goes through the vertex. So the axis of symmetry is this imaginary vertical line. And it's a vertical line, so it's x equals, and to be x equals the x coordinate of your vertex, which is negative 4. Okay, number 2, we're going to be looking at absolute value equations again, just kind of an extension from the first 9 weeks. So it says solve the following: x plus 15 equals 4x. So we still set it up the same way. I still take what's inside the absolute value and set it equal to what's on the right hand side, and take what's inside the absolute value and set it equal to the opposite of what's on the outside. So this, I would subtract x from both sides, so I get 15 equals 3x. Divide by 3, so I get 5 equals x, and on the right one I'm going to go ahead and subtract x from both sides, and I get 15 equals negative 5x, and then divide by negative 5, so I get x equals negative 3. Now since we're dealing with a variable on the right hand side, we need to check and see if either one of these don't work. So if you kind of just do it in your head here, if I put in 5 for x, 5 plus 15 is 20, the absolute value of 20 is 20, and 4 times 5 is 20. So this one works out. If you put in negative 3, you get negative 3 plus 15 is 12. So the absolute value of 12 is 12, but over here 4 times negative 3 is negative 12. So this one doesn't work. It's called what we call an extraneous solution. So the only one that actually works is x equals 5. Number 3, solve systems with elimination. So we got negative 2x plus y equals negative 1 and 3x minus 2y equals 5. Again, several different ways to approach these. I'm just going to kind of keep it the same I've done since you guys were in Algebra 1. Is we can always put parentheses around both. Since I've got opposite signs already, then these numbers can both be positive. So I just take the 2 that's on top, I'm going to multiply the bottom equation by 2 and the top equation by 3. So this equation becomes negative 6x plus 3y equals negative 3. And the bottom equation becomes 6x minus 4y equals 10. So now I'm ready to add the two together. So this negative 6x and 6x would drop out. 3y and negative 4y is negative y. Negative 3 and 10 is 7. Then I would have to divide by negative 1. So I get y equals negative 7. Then it's just a matter of picking which one you want to plug into. I could do the top or the bottom. So I'm just going to pick the top equation. So the top equation is negative 2x plus y equals negative 1. But now I'm going to plug in a negative 7. So negative 2x plus negative 7 equals negative 1. And to get rid of the minus 7, I have to add 7 to both sides. So I get negative 2x equals 6. Divide by negative 2. X equals negative 3. Then again, write your answer as an ordered pair. So it'd be negative 3, negative 7.